Okay, assalamualaikum. So today we will start this topic that is all about sensors. Okay, so our topic is sensors. Fine. Okay, it's not about the sensor board that you are very much familiar with it, like the cinematic sensors or the meteor cord. Okay, it's not about that. It's something that we have discussed about it in our first class. Okay, like in basic robotics or in basic microprocessing unit, there are some sort of things that you can't deny that, and obviously that sort of thing is something like we can divide it in 3 blocks. Okay, 3 blocks. One is input, again another is the processing unit, and the ultimate one is the output. Okay, so what is an input? Like if I say f of x is equal to y is equal to 5x plus 3, then I can put the value of x any kind of all real number or the all natural number. Is that so? Then we will get the value of this equation, and that will be the y and f(x). Okay, so I can say any kind of value of x. I can imagine any kind of value of x. So that x is what? Is a variable where I can set my own values. Okay, so x, so basically y is totally dependent on x. So y is a dependent variable and x is independent variable. Okay, so the thing is, right now I'm living in this room, I'm taking the class in this room, I'm feeling cold right now as the AC has been turned on. So it seems that I can feel the cold, I can feel the less warmth, I can feel the less humidity and other stuffs in this room just because of the AC. Okay, and my body is capturing that coolness, that cool breathing. It's just because of it is taking the input, and it is also showing that yes, whenever at the time of taking the inputs, it also process, and as a result, what's happening there? As a result, it is indicating that I am feeling, and I feel that, oh, okay, it's cold right now, and that feelings come from my mind, okay, not from my body. So actually, the AC has been turned on. Okay, thus the AC has been turned on. I can feel the cold. Is that so? But it's not like that. The AC has been turned on. I am feeling the cold. I am feeling that the room is cold. Okay, the room is less warm. So these feelings has come up from my mind, and these feelings has come up from my mind with the value of what? Cold air. Okay, just like the cold, that feelings I can feel as a what? As an output. Okay, the feelings. So these feelings has been processed in my mind. So my mind is a processor. Okay, and this cold again, whenever it comes to my body, okay, it comes, it's attached to my body with a little small amount of particle, okay, with small amount of coldness. Then my mind processes that something has come up to my body that has been attached as a particle, and that particle feels me. That particle believes me that yes, it is cold right now, and these beliefs come from my mind that has been processed over there, and this feelings is working as an output or show as an output, and that particle, whenever it comes to my body, that body take it as an input. Okay, so the feelings is the output, the processing is a mind is in my head, and whenever this coldness has come up and attached to my body as a particle, then I have that feelings. Yes, something has come up and touched my body. Like if I take up my hand, the cold air, what is trying to pass in through my hand. Okay, so I can still feel that yes, there's something over there. If my mind has been collapsed, if my brain is not going to work, then I can never feel that charm. I can never feel that cold. Okay, so everything has a processing unit. Everything has obviously its output, and everything has its input. And thus, you can say this input work as a sensors. Okay. So now you can say what is sensors. So in theoretical knowledge, I can say it's an agent. Okay. What is an agent that detects the environmental parameters like pressure, temperature, altitude, humidity, weight, color, anything, okay, and produces proportional electrical signal. See? So any kind of environmental parameter that produces what? Electrical signal. Now my question is, whenever I can feel the cold, I can feel the warmth, is there any signal produced over there? Obviously, but it comes to my mind, and you can generate signal over there as an electrical signal. If you take back and look back as a best example, ECG. So your heartbeat is a beat, but they counted the beat per second or beat per minute and show you as a result as a BPM that causes the heart rate, that causes the signal of your heart and how it works, how it moves, and how it reacts. Okay, and this is the basic example that here shown. You have seen in the movie, like something is like that. Tick tick, tick tick, tick tick, tick tick. Okay, so that's the basic example. So like this, we can say. So what is the output over there? The display. What is the processing unit inside the machine? The processor. And what's the input? Your body with the physical contact or the contactor that has been connected to the body as a pad. Okay, the round pad. So I think now we have got the ideas about sensors. Okay, and another sensor I can say as a basic example, like weight machine. See, whenever you stand on a particular weight machine on a coverage on an area, it calculates the area in terms of your pressure, like P is equal to F by A. So it calculates the pressure, and that pressure converts into what? Electrical signal. And then that electrical signal will convert as a value. And that value you will show the monitor or display. Okay? And that's why you can say, yes, it's 52 kg. It's something like that. Okay? So every transducer, so here comes the importance of transducer that has been learned, that has been taught by your teacher on measurement and instrumentation course. Exactly. So that's the most important course where you can learn how a sensor built and how a sensor is going to be worked. Okay? In this course, you are going to learn how this sensor react or interact with the microprocessor and how this signal converts into output. You get my point? That's the basic one. Where you can build over there with the transducer, with the pad, okay, the value, how this, the theoretical idea, how these pressures convert into electrical signal. The conversion, that's how you can, that's the things you can learn from the previous course. Okay. Now you can say, like for example, LM35 is a temperature sensor. Okay. What? LM35 is a very common temperature sensor that has been available in market. Like it costs only 50 taka or something like that. Okay. So this temperature sensor produces electrical voltage of what? 250 millivolt. How much voltage may it produce? 250 millivolt. And then when it is 25 degrees Celsius. So as the ambient temperature, it is the standard temperature, in 25 degrees Celsius, it produces 250 millivolt value, okay, as a voltage. So now, if I can say, please open up the calculator or copy, for a particular 1 degree Celsius, what will be the ultimate voltage? For a unit voltage, for a unit temperature? What? 25 volt? 25 millivolt. Okay, so it's 25 millivolt. Now you can say that it's 25 millivolt. Is the screen clear? The video is clear? Yes. Okay. So the sensor produce. Now my question is, what will be the output voltage whenever the temperature rises 30 degrees Celsius? What? Why are you calculating this? 300 degrees, 300 millivolt. So that's the basic thing and the important thing about LM35. Now we have a little chit chat, gossip about this LM35. That's why you can understand the importance of LM35 and how we interact with the Arduino, how its legs, I mean the pin numbers, has a significant role to connect to the Arduino and how they interact with each other. Okay? So if I say, I have to take just a simple value, just a portion like ABC and like whatever I can take channel 4, like CH4, any kind of value like A4, A5, A6. So can you say LM35 is it an analog sensor or a digital sensor? How do you get to know about this? That LM35 is it?
Capture analog signal or physical signal.
Okay, so you think that it's an analog sensor, right? Please Google. It may be analog sensor. Sure. Okay. As per your concern, LM35 is an analog sensor. So, how many legs will be? How many legs of LM35 will contain? 3. Now,
if input and output and what is power?
okay, so it has analog output voltage, right? So how many pins does it contain? Like one is 5 volt, one is ground, and this is what?
Output.
The signal pin. Signal or output? Signal pin. Okay. So now you have to power up this 5 volt and ground. You may connect another battery source, or you may connect with the Arduino Uno. There's a 5 volt pin, there's a ground pin. Okay. So you know that you have to connect the common ground as they're connected with each other. Okay. So you can connect this 5 volt over there. Now this signal is very much important that can produce the analog value. Right? So this signal pin should be connected with this channel. Like the Arduino Uno is a big one, a very big one. It has lots of pins over there, digital and analog and PWM pin and others pin, feed reference pin. Okay, TXRS and others pin as well. So now we have to focus on how we connect and how we react each other. There's obviously a feed reference pin over there. So it's ADC and VFR. It's not important to connect with the 1.1 volt. It's just to make sure that 1.1 volt is very much convenient whenever you connect with this 1.1 volt with the feed reference pin. So that's how you can connect with this what? LM35 whenever it has a T degree Celsius, T may be 20, 25, 30, 35, whatever it is. And this 735 has an accuracy of 0.5. Is it 0.5? Yes, 0.5 degrees Celsius. Constant 0.5. So it varies, like you get the value 20 millivolt, you get the value 30 millivolt. Maybe, then what will be the temperature? Please. Whenever the millivolt, whenever the output signal or the millivolt output voltage is 50 millivolt, so what will be the temperature at the time?
500 degrees.
What?
500 millivolts.
I asked you that I have found a voltage over there that is 50 millivolts. So what will be the temperature over there? 5 degrees Celsius. So this 5 degree will be something like 4.5 or 5.5 within this range. So that's the call accuracy. So yes, that's the accuracy actually. Okay. So that's the basic you have learned about this, and that's how it works. And there is a formula over there. Okay. The formula is, you have to memorize this formula. T degrees Celsius is equal to 100 into VDT. That's the formula. And this VDT is connected with here. VDT A4. Channel 4 means A4. Yes. Yeah. So what is VDT? Please write down that VDT is a DC voltage at sensor output pin. So it's a DC voltage, 50 millivolt, 500 millivolt, 100 millivolt, whatever it is. DC voltage at LM35. Okay, DC voltage at LM35, output pin, when it is T degrees Celsius. So T may be varies 25 degrees Celsius, 20 degrees Celsius, 5 degrees Celsius, 50 degrees Celsius. Okay, fine. And now I can say that T degrees Celsius is equal to what? 100 into whatever I can write over there. Can you say please? V reference by what? 124. Sorry, 123. Why 123? How many values over there? 124 analog values. So 0 to 123. How many values over there? 124. So V reference divided by 123 into what? Into A4. Okay? It's analog read A4. So the value of analog read will multiple or times V reference by 123. Okay? So that's how it works. That's the basic formula. And after getting the value, if you put the value over there, then you get the temperature. Okay? So you know what is the value of V reference? Is 1.1 voltage. That's 100, that's 124. And what is the value of A4? So it is not like A4, it will be analog read. So could you please tell me, does it look like analog read or does it symbolize to analog write? What will be the ultimate answer? Analog read or analog write? Analog read, because you are getting the temperature from the environment. The cold air is going to touch your body. It's going to come up with the body, have the attachment with your body. Okay? The sensor takes the input, not the output. So whenever it takes the input, see if you have a book in front of you, what you have to do at the time? You have to read exactly, and then you have to write. Without reading, how could you write about that? Is that so? So you have to read that, and then you have to write. That's the basic thing, and you have to focus over there. Okay? So that will be A4. It will be analog read. So R will be the caps lock. Read A4. Why A4? Because I have planted the pin at child number 4. That consider the A4 of Arduino Uno. Okay? So I am not going to draw this whole thing. If there is an interaction and a connection over there, so draw this, just this one. and write this equation, then you get the full marks. So the question will be something like that. Specify a pin. Okay, I'm going to work with a specific pin like A5, and the sensor is going to be read out the value or exploding the value through this A5 pin. Do you get my point? I am going to build a setup with the Arduino Nano, that is going to be connected with the LM35 sensor, whereas I have to explode the environment and take the read from the environment with the pin number with channel 5. Now build this connection. Do you get my question? I'm again asking to you. I'm going to build a setup with Arduino Nano with its pin number with its channel 5, whereas I want to get the value of the environment or the temperature of the environment with the LM35 sensor. Now build up the setup. What will be the changes? Simple. Arduino Nano, channel 5, A5, and all the rest should be the same because you are not going to change the LM35. So you have just changed the what? Arduino. So if you write the Uno, if you write 4, then I will understand you have memorized this shit. Okay? But that's not the memorizing thing. That's the important thing you have to learn. What? That I am talking about channel 5 and I am specific that channel 5. So here, if it comes to channel 5, then what will be the analog pin number? A5. So what will be the changes over there? A5, and everything will be the same. Because you are not going to change the LM35. You are not going to build another sensor like LM36. Okay? It's not going to be possible over there. So the fun fact is, you have to understand the question. So you have to draw this schematic diagram. So it will take 30 seconds to 1 minute maximum. And if you write this line, it will take 1 minute. So within 2 minutes, you will get 6, 5 to 6. And if you want to understand this thing, you will get double 0. And I will make sure that whoever will make this mistake, to memorize this, he or she will get double 0 over there. That's my promise. Okay? Because you have to understand. It's not about memorizing. Okay? The question is very much easier, will be very much easier because the parameters, the content are very much easier to understand. Just have to focus on that. Okay? So then there are the digital type sensor like DS180 most probably. Yes, DS18B20. DS digital type sensor, and that's obviously a factory calibrated sensor. And the output is in digital form, not in the analog form, as it comes to digital form over there. So they will be the same, like it will be D5, it will be channel 5. Okay, so all connection will be the same. Okay, it's not very much critical, but over there you can connect a register. The register will be like 4.7K, and the signal pin is going to connect with what? 5 volt. Why the signal pin? Why the signal pin is connected with the 5 volt like this? Because the 5 volt, because the 5 volt has connected over there, and there is a drop over there current, and specific voltage will be occupied through this wire. Okay. In analog, we don't have any concern with the analog. Yeah, with the value. But in digital sensor, you have just additionally connect a resistance from which end to another end. That is 5 volt signal. The same connection and everything will be the same. Okay. Now you can connect channel 5, but yes, you can connect channel 5, channel 7. But it's very much easier to make sure that D7, D5, D6. Okay, then it will be easier, and everything is the same as before. There will be no change over there. Yes, and the code will be the same, and that's very much easier. And we would love to use that value DS18B20 sensor. Yep. That's very much easier. Then you don't have to connect to the reference pin. You don't have any kind of ADC, just nothing like that. 5 volt, ground, 5 volt, nothing. And user access is very much easier to use. But the fact is, whenever you use a collaborative value, whenever you are collecting the value, analog would be the preferred to work on that because you have a long range of values. Okay, so it's not a big deal. I can work with the both sensor. So that's it for today, and I hope you enjoyed the class and learned about the sensor, the basic of it, and how we interact with the voltage, how it interact with the analog value, how it interact with the channel, and how it create a result with particular mini voltage in the collaboration of Arduino Uno, Nano, and the sensors. Okay? So that's it for today. Close the video.